Okay, so we've got this clustering, but we don't really know what represents those two clusters. And if that's the case, what we can do, if we can't easily spot a rule for deriving what those clusters mean, we can return to overlaid radar plots. Okay, so first let's do this for the two clusters that we do understand to make sure that this gives us a sort of sensible picture. This code is exactly the same as the radar plots in lecture 6, example 6, except that I'm for this example, I'm selecting the low ratings, so selected is just the low rated products here. Okay, normalized data is the ratings divided by the ratings because I want to normalize everything so it's between 0 and 1. And when I do that, that's the picture I get. Okay, we knew this cluster had low rated products, but you can see the ratings for all these products are consistently low, except for rating 3 and rating 8, where they can be low or high. So some of those ratings are low, nearer to the center. Some of them are very high. So whatever is determining this cluster, it seems to be it's anything, all the ratings 1 up to 10 are consistent, except for 3 and 8, where it doesn't seem to make any difference. It doesn't matter what those ratings are; they still the product still gets put in that cluster. If we do the high ratings, so same code, but now we've picked out the high ratings, what happens there? Actually, we get a very similar picture. The ratings for these products are consistently high, except for 3 and 8, where they can be high, or that's sort of medium, they can be low. In this, on rating 3, they kind of look like they're all medium. So again, if they've got high ratings in rating 1, 2, 4, 5, 6, 7, 9, and 10, then they go in this high-rated cluster. But the ratings for 3 and 8 don't seem to make any difference. So in a sense, you could say, from what we can see so far, it looks like 3 and 8 are kind of not very important to the clustering. The ratings 3 and 8, they're just like a random value that doesn't make any impact on the clustering. Let's try the unidentified clusters. So for example, 11 it's exactly the same code for these 4 examples. I'm just picking out different selected values. That's the picture I get for example 11. Okay, so we can see there's high ratings for 4, 5, 6, and 7. So these ratings around here. Rating 3 can be either high or low. There's rating 3 on that line. Rating 8 looks like it's, where's 8? That's 8. Look, that can be high or low. So those can be high or low. And then 1, 2, 9, and 10 are all low. Whereas if I look at the clustering, the other cluster, it's almost exactly the other way around. So the rating 3 up and 8 can be effectively, they're random. They don't seem to have any impact. But ratings 4, 5, 6, and 7 are low, and 1, 2, 9, and 10 are high. Okay, so if we ignore the ratings 3 and 8, they're not really telling us anything about how the data is clustered. The ratings data falls into 4 distinct clusters. One where we get high ratings for all the others, so 1, 2, 4, 5, 6, 7, 9, 10, or one where we get low ratings for all those 8 rating categories. One cluster where we get high for one half and low for the other half, and one cluster where it's the other way around. It's low for one half and high for the other half. Okay, so that's actually enabled us to identify really clearly where these clusters are coming from. Okay, but why we couldn't do this manually, why it's much harder to do this manually, is that 3 and 8 are really distracting. They're just noise in a sense. In terms of this clustering, they look like they could be high or low, but they're not having any impact on how the data is clustered. So that makes it, if we're going back to the original radar plots that we saw at the beginning, that makes it much harder to detect similarities in shapes. But when we've done the clustering and when we do these overlaid radar plots, then it becomes much clearer. Okay, let's finish that video there, and then we'll look at the summary data for the products that we've seen in other lectures.